somebody last night, I don't remember who it was working in the shop, and I said, what are you doing? They said, we're just here to work in the shop. And I said, okay, if you're not doing anything really important, like they're sweeping the floors or something, I'm going to be talking about tire mounting and balancing. Could you clean up my rims here? And he said, sure. And I almost feel bad to mess with the tire that clean. But anyway, okay, so these are the rims we're using, and these are, see if I can find the size, 205 60/13s. So these are 60 series tires, which are about the highest profile tires you'll see on the road today. Used to be really low profile, but whatever. And in Legends, they require you run a street tire, so they all have tread. There's no racing slicks here. So these should be about as easy as it gets. And because they're steel rims, after everybody's mounted and balanced these tires, you probably won't have damaged them. If they were the rear tires on your Lamborghini, they'd probably be destroyed by the third person because those are real tricky, but these shouldn't be. Okay, so the first thing we're going to do is we're going to let the air out. And I don't know what happened to our fancy tool, so we're going to use this one. This tool has a couple nice features. It's got like a die, so you can cut threads on a Schrader valve that's got the threads that are damaged. And the internal threads on the Schrader valve, you can cut them as well in case they're damaged. And if you destroy the Schrader valve, the little guts of it, the valve part, little valve part, it's got this little pointed thing. You can dive down in there, and left-hand thread, you can try to get that valve core out, pull the valve core out, get back to business. On the other hand, the last part is this little tool that lets you take the valve core out of the Schrader valve, or lets you take the Schrader valve out of the valve stem. And so we'll rotate that, take it out. Now when I take this thing out, the pressure will be so high and the ambient pressure is so low that it'll go supersonic. Hopefully it'll go like woo, and then after a while it'll go wee. When it goes wee, that means it went subsonic, and now it's coming out at subsonic speed. So there are not many times where you hear the supersonic flows, but on tires you will. Maybe not. Sounds like it's just low on pressure. But if you've ever heard tire shops take the tire stem out, make this hissing noise, and then it makes this transition to a lower pressure. Maybe the next person that does this will pump it up to 40 psi and see if it does it then. Okay. There's no air in the tire now. It's deflated. So now we'll take it over to the bead breaker. And the bead breaker has these two tools. One takes it out, one brings it in. And you can see the shovel can be rotated back and forth and up and down, so you want to get it in there correctly. As of about 2014, all cars had to have TPMS, tire pressure monitoring system. Oh, I think it was much earlier, maybe 2007 or so. Some, like early Chevrolets, they use the encoders from the anti-lock brakes, and if one tire starts running faster than all the others, they assume that that tire's got low pressure, and it'll give you a low pressure warning regardless of what the tire pressure is. Most today have TPMS sensors, tire pressure monitoring system sensors, and they are mounted typically right in the valve core, so that you buy a TPMS sensor and it's got a valve core on, a valve stem on it, and you stick it in there and you pull it through the rim, and it's mounted back there, and it's an electronic device with a pressure sensor. If you dismount a tire and you come down to where the valve core is and you start right there and you take it off, you will then peel off your TPMS sensor, and before you're done you're going to have to replace it as well. So the recommended procedure is to not start where the valve stem is and work your way around. Try to avoid that little matchbox size electronic piece of technology that's in your rim. All right, so we don't want to do it there. We'll find some place nearby and do it there. And of course we do it with the drop center out first. And it pops off the rim, and then we move it around to a new location. And if it was your Lamborghini, you'd have to do it every 5 degrees. But in this tire, it's maybe already completely dismounted. Even though we only did it once, we tried on the far side. Yeah, okay, I think it completely dismounted itself in the first try. I did the rear tires on my Porsche. And I assure you, it took like 30 bead brakes to get it to come loose. It was really not eager to come off. Now on the back of the tire, because the drop center is so far away, it might take a little more work. This time. All right, I think it's completely broken loose. Yeah. Okay, again, here are the sharp teeth. These are what make those marks on your rims that you see when you take it to a tire shop. And then this is the side we'll be mounting on, grabbing onto the wheel rim itself. We'll go ahead and take that weight off. The way the tool works is the weights have these little gaps in the back, and the tool grabs into that gap area, and then you peel it off this way. Oh. Now we'll stick it on here. What I'm going to do is hold it up a little bit. We'll get a little closer. And there's not like an adjustment. You just press it until it grabs it and it runs out of steam. And then there it looks like it's nicely balanced, or nicely set up. So depending on the size of the rim, you adjust this thing here. So what we're going to do. Okay, so it happens to be adjusted about perfectly right now. Maybe it comes in a little bit closer. I want to get it down a little bit farther in this cam lock mechanism. Release it, pulling the lever forward, pull this down until it's nice and snug against the rim. Now ready to go. If we're doing an alloy wheel, this tool would be mounted this way so we don't damage the rim, but since it's a steel rim, we won't waste our time. Stick it down in there. And then this side's going to be down. Push down in there. Get it all the way past the rig bead. You got it? No, it's got to go on this feature right here. If you look at the shoe, there's a little grab area. You good? Make sure this is down and pull it up and over. This is not a delicate process. There's a lot of force involved in this. So now we've got it up on there, we can take it around. There's not a lot of instructions on this machine. Everything is about where you would want it to be when you need it. So when you're doing this, the tool is sitting right here. When you're standing in front of the machine, the pedals are right here in front of you. When you get ready to remount the tire, when you get ready to reinflate the tire, you'll be standing over here and there's a pedal down here. And so it's sort of a unmarked logical thing for it to happen. For example, on this side, when we're mounting and balancing, when we're balancing, this pedal down here will be giving us different different functions as we need them, and they just happen to be right where we need them. So right now, we got this thing on here, and then we may want to lube the tire. There are different kinds of lubricant you can get. This is kind of a soapy stuff. We'll put it around there. And we really only need it to be on the bead area of the tire and the bead, the edge of the bead of the rim and the edge of the tire. I'll explain that a little bit better when we get the tire off. I'll show you which part I'm talking about. But basically, it comes down to where is it going to be sliding. It's not going to slide way out at the edge of the bead area. It's going to be sliding down at the bottom of the, the bottom of the tire, and the edge of the rim is where they're going to be sliding, and those are the critical places. And pull it back up. Get the other side, the downside down here in the drop center. Pull this up. Is it in the drop center? Oh, before I do this, let me talk about this a little bit. So on this shoe down here, there's a big hump, and when you're dismounting it, you want the tire to come up underneath the shoe, underneath the shoe, and then over that hump. And you'll put the tire tool in front of the hump, and the shoe sits out, and it's got a little lip on the edge. I'm going to go between that lip and the hump, and it has to stay on that hump to come off the tire. When we put it back on, it has to be underneath the hump. It should look logical when you do it, but just to explain what that hump is all about. If it gets off the hump, it's not going to work. Anyway, bring it up. Got it over the hump. There we go. Okay, so what I meant is, when you're taking it off, you want this part to be lubricated here, and that part of the rim lubricated as well. It doesn't really have to be lubricated up here. All right, we'll go ahead and lube it now that we got it. And by the time the last person does this, this thing will be so lubed up. When I was at Michelin, we mounted and balanced tires all day long, and we had this one giant guy, just a real soft-spoken, pleasant person, who came into work dressed very nicely every day. But he put a suit on like I did and then mounted tires all day long, and I saw him literally throw a tire on a rim and seat it without using a tool. And I thought, well, be nice to that guy. Anyway, so notice that when I pulled this thing back, I didn't raise it up. It's sort of not necessary once the tire's completely broken loose. And you can see we don't have a, there's no TPMS on this tire, on this rim. So we come around here, and although it's helpful to have Jugal helping me, in any tire shop, there's no Jugal standing there. It's the tire guy by himself. Again, when you're mounting the tire, it has to go over the back of the shoe and under the hump. All right? So put the shoe in there, get where we want it, put it over the back one, bring it in the front, and the farther around we can get it, the better off we are. So, wrestle this thing around. Well, almost mounted it. All right? Watch your fingers. Okay? We do it on the same on the front, on the top. This is going to be harder because the bottom of the tire is trying to prevent it. And it's got to stay underneath that hump. Now that it's about halfway around, it has to be down in that bead area. If I don't get, that drop center, if this tire doesn't go down in the drop center and I continue, I will destroy something. The tire or the rim, I'm not sure. In this case, probably the tire. there. I gotta back it up. Try it again. Now, if you look at it, it's down in the drop center. See how far down the bead is? It has to be like that. If it's not down there, you'll damage something. All right? Oh, Samola. Yeah, didn't see that coming. All right, move out of the way. So pay attention to what you're doing. Watch your fingers. You don't want to be between the tire and the rim. So stopping in the middle of the process may not be a good idea. Right. Then the next thing is we'll inflate the tire. Why can't we inflate the tire? No, the valve stem's not it.
Still clamped?
It's still clamped on the rim. Now, prior to this guy cleaning this thing up, it was grease everywhere. It's not quite so greasy this time. Okay, now it's not in the rim. It's not clamped inside between the bead and the tire. You can do it. Gauge over here. Troublesome tires, 50, 60 PSI. I think they say if it goes above 40 PSI, you sink the bead. Take the tire out and mount it in a cage. If you go to tire shops, you'll see these big steel cages. You know, they're like this big. You put, almost always put truck rims in them to inflate them. But if you have a passenger tire that just will not seat, you put it in a cage. You take it to 100 PSI and it explodes, you don't want to be around it. So it reads 40. Now what we'll do, we'll let it completely deflate. And that lets the beads and the rim area seat correctly. Tire shop would normally not do that because it doesn't really change much. But we're not a tire shop. So go ahead and take it all the way down. Once it's completely deflated, good. Pressurize it back up. Again, the pedal's where you need it to be. And if you overpressure it, there's a pressure relief on this side. We'll take it up to 30 PSI. 40. Now we have a valve stem in there, so when we take this thing off, we'll lose pressure. So we'll get the valves for the Schrader valve. Put it down there. Down in the hole. Threads it on. Did you do that before you pump it up? I guess you could. The question I've got is, I don't know how long it takes to pump it up if it's got a valve for it. It's hard to push it through the valve. Good. And this thing, it's got a little lock mechanism in it that grabs onto the valve stem. It also grabs onto this big Schrader valve up here. Now, when you mount tires, typically what people do is they use these little cone things, and you find a cone that's the right size to center up in this thing down here. And each of these cones has a big and a little size to give you a range. Right there, it looks like we're good. So let's take it, because it's the green circle facing out. We'll stick the green circle facing out, slide it up on there. Then we'll take this tool, which screws on there, and this tool has adapters for aluminum wheels that are rubber and will protect your aluminum wheel. And since we're using a steel wheel, we don't need that. Likewise, we could also try it with what's called a pin plate. And a pin plate is for rims that are not pilot centered but lug nut centered. So some rims are lug nut centered, some are pilot centered. If there's a pilot on the hub, if you look at the hub where the tire goes on, it'll go up to where it's about to mount, and then just as it mounts, there'll be like a slightly larger diameter. It looks like a real precision diameter, and that accurately aligns the tire. Some don't do that. Some use the lug nuts to do that. And if it works that way, then what you do is you use what's called a pin plate. And these are adjustable where these things come out. And you can put 3, 4, 5, 6 lug nuts in there. And then these align it, and these slide on accurately onto here and align on this rim to the lug nuts. And in fact, I've done it on this tire, on this rim, and it doesn't work well because being a race car, these lug nut centers, where the lug nuts go, are really chewed up. Look like someone took a, I don't know, die grinder or a hammer or something to them. They're pretty chewed up. So we're not going to use the pin plates on this one. We'll use the taper. You can't use both. And when you use the pin plates, you have to take this thing off or it won't fit. There's a little spring back there, so as it gets close, it'll start getting tight, but it doesn't get tight like rock hard first time you touch anything. There's a little bit of springing involved. So right now you can feel there's a little bit of play. So typically you want to mount it, bring it up, jiggle it. You see how much it turns. Right before it locks down, I usually try to wiggle it around a little bit just to make sure there's nothing, not a little blob of crap in there that prevents it from being aligned correctly. If you're mounting truck rims, sometimes the pilot is really big, in which case then you have different adapters that go on there to allow different size rims. And that there's a bigger one for trucks as well, these, and it has the aluminum part as well. Okay, so I think I've got it on there. Good. Now what we want to do is we want to tell it where the balancing surface is, meaning if you just put a weight on in the middle of the rim, if the rim has an offset weight here and here, it may say that it's balanced already, but when you drive it, it'll be, it'll be shaky. So there are planes onto which you mount the counterweights to balance the tire, and the machine needs to know where those planes are. And it's nice in that when you're doing this, it's got this little tool right here, and it'll let you do first things first. You have to tell it what kind of weights it takes. So there are hammer-on weights and stick-on weights. And the hammer-on weights, you just hammer onto the metal rim, and the stick-on weights, you sort of bend up and you stick to the inside of the rim. It has to be really clean or you'll throw the weight off and then you'll lose your balance. And so if you don't balance it correctly, let's say it says 1.5, you stick it on and it says, oh, 0.25 on the opposite side. You think, well, that's the same as taking 0.5 off or 0.25 off. And the way you do that is you take them all off, clean all that double sticky tape out of there, start over, and try again. So we'll probably ask it 2 or 3 times before we're confident that we have it mounted up okay. Because if there's a little bit of crud under there and it's not mounted correctly, it'll vary in its readings. The other thing is there are a lot of different rims, and I don't know why people do different rim profiles, but there's IAW and MC and AW and P and FN, and they all have different shapes to the way they work. I'm not sure the logic why they do them, and you really need to go and look at your rim and figure out which one of these profiles matches the rim here, and this one is a P, I think, so let's see how the P fits. Oh, just like a champion. And likewise, we have a whole bunch of P weights and EN weights and LH weights, and some have nice coatings on them so they don't get all crappy looking. You figure out where that goes and put it back in the car. And they have different masses to them, so you have to know which one you're going with. We just happen to have a P, so we use P's. The next thing we have to tell it is where they are. So first thing is we'll say it's a hammer-on weight. And it says 2 hammer-on weights, or a hammer-on the outside and a stick-on the inside, which is what my Mercedes uses. I hammer it on here, but I don't want to ruin the aesthetics of the outside of that rim, so there's a stick-on weight on the inside.
How do you,
or 2 stick-on, or 2 hammer-on.
how do you put the stick on inside when you already have it full of pressure? You would have to dismount the tire first in order to get inside
Oh,
the rim?
no, think about it. They can't be inside the tire because the centrifugal force will throw them off. They're mounted inside here on the outer, on the interior surface, but not where it's pressurized. They're on this side.
Right.
So that the centrifugal force holds them snugly against there. Racers often put them on and then put duct tape over them to maybe give it a little bit more assurance they won't fly off. Okay, so anyway, we told it there are 2 hammer-on weights, and then the first thing we're going to do is we're going to take this thing, and it's got a little top hat. We'll bring it out here to the bead area where the weight goes on, and I'll step on this pedal, and it says, got it. I know the diameter, I know the offset. And then on a stick-on weight, you would bring it up inside there and you put it up where the stick-on weight goes, but in this case, it's a hammer-on weight on this side, and we have this tool here, and it goes on. We bring it up to where it's touching where the weight's going to go. We tell it to. So now it knows where all the weights are mounted, the diameters and the offsets. Okay, then you just lower it. Now when I lower it, it'll start turning and it'll start analyzing the counter, the balance weights that it needs. But the other thing is you really should stand over here and look at the feed area. If that tire is going like this, then you probably need to go back and do it again. So we're hoping that it'll be pretty centered. It actually looks pretty good. It also has a servo drive that rotates the tires, and the servo drive, because servo motors have encoders built into them, it'll also position the rim where it needs to be to put that first weight on. And so what it says is you can hammer on the weight in this orientation, 1.25 right here. So it says I can hammer on right there, and I take this tool, I take the weight, I would just hammer it on. And then you can either tell it next and hit go and it'll orient to the next one. You can do this one, or you can just tell it to break loose, and I'm going to find where this one gets mounted. Right there, light turned green, one ounce right there at the top, and I should be balanced. So it's 1.25 and 1.00, and I'm going to say, I'm not sure how good I am, so I'm going to take it loose. I'm going to see if it gives me the same numbers. Well, it seems like that 1.25 won, but I'm not very good at this, so I don't believe it. It seems pretty confident that's what it needs. It is not uncommon for it to read differently when you do it again, depending on how clean the rim is, that kind of thing, and the centering. And the other thing is, it has a tolerance of 0.29 ounces. So if it says 1.25 ounces, and it means 1.25, and I put on 1 ounce, it'll go, oh snap. And it won't say 0.06, it'll say 0. So the minimum it reads is 0.25 because we only have, that's the smallest weights we have, so there's no reason for it to go more accurate than that. And a niche is going to find out how accurate it is. Okay, so it said 1.25, and it's a P. So when we do this, we typically throw the old weights right here. And these are old weights and these are new weights. We're going to look for a 1.25 P weight. I don't see anymore, so we'll still look for a new one. 1.25. The way this works is, you take it, you hold it up in there, and then you hammer it this way. So the steel part's like this, and you hammer it this way to get it to go down in. You don't hammer it this way, and when you pull it off, you don't pull it off this way, you pull it off this way. Does that make sense? Kind of seems logical, but it's easy to get it backwards. So it says right at the top, put it right there. How close am I to the top? I don't know, hopefully pretty close. And one on the other side. Let's see, one's out here, so. A P and a 1. Oh, I need to orient it correctly. The servo motor's trying to hold it, that's why I released it with a pedal.
If you hit it again, does it lock it?
I'm not sure. It's got a bunch. We had a problem with the alignment machine, and the Hunter guy came in and he talked about it. He says, oh, well, if it does this, then hit the button twice in quick succession. I said, well, that's not in the manual. He goes, the manual doesn't tell you all the things it does. Maybe. The other thing is, there's a thing about it. So this thing normally sits back here like this, because normally you've done this 3,000 times in the last week. You don't really care. But since we're learning, there's a bunch of interesting features here, such as split spoke mode. So if you have spokes like this and you don't want to have a nasty old weight there, you can actually like split the weights and put them on either side of that spoke. Servo aided weight placement. Let's see if we can get it through this.